Hi, this is Karthik. In this session, I'm going to teach you Introduction to Computer Architect. What is architect? The term architect refers to the base design of a computer, or the term architect refers to basic design of a computer. This diagrams gives you the complete picture of a system architect. This diagram have three main parts. First one is input device, second one is system unit, and third one is output device. And moving to input device. Input device is used to provide data to system unit, or input device feed data to system unit, where the system unit will process the information, and the processed information will be displayed or will be shown using the output devices. And in case of secondary memory, if you want to store the processed information, yes, you can able to store using secondary storage devices like floppy disk, hard disk, CDs, DVDs, flash drive, etc., etc. Now we'll see example for input devices. Keyboard is an input device where we can able to give text input, or keyboard is an input device where we can able to key in the data. And mouse is a pointing device, and light pen is a digital signature. Using light we can able to create digital signatures. And microphone, it's a sound input device where we can able to use sound as an input device. And scanner, whenever you want to provide an image as an input, you want to use scanner. And next comes system unit, which is the core important. Here the system unit consists of RAM, RAM, random access memory, and ROM, R for read, O for only, M for memory, a hard disk, processor, motherboard, etc., etc. This entire thing put together as system unit. System unit is used to process the information. And output devices, the processed information can be shown using output devices like monitor, printer, projector, plotter, etc. This diagrams gives a clear picture of a computer. Here we'll be having input devices. The input data can be given using input devices. Example for input devices: keyboard, mouse, light pen, scanner, microphone, etc., etc. Where this input will be processed in system unit. The processed information can be stored using storage devices or backing storage, as well as if you want to see the processed information, you are having output devices. Let us say monitor, printer, plotter, projector, etc., etc. Now we'll see input devices. Here the input devices, example mouse, keyboard, light pen, joystick we are using for gaming, and scanner, etc., etc. Here you can able to see this picture where this is called as keyboard and this is called as mouse, where keyboard is used to provide text input and where mouse is called as pointing device. and this one is called as microphone, and here the sound is an input, and this is a digital pin. Whenever you write on this, the signature will be converted into, the signature is taken as an image. Whatever you write, the return will be taken as an digital word. And next comes scanner. Whenever you want to give an image as input, we can use scanner. Next comes web camera. It's in whenever we want to use image and video as input, we can use web camera. Again, I'm repeating, keyboard is used to provide text input, mouse is a pointing device, microphone sound input, digital pin is a digital input, and scanner is an image input, and webcam either image or video input. So these are known as input devices, where these devices are used to provide data to a computer or used to feed data to system unit or a computer. And next comes, what is this? This is called as system unit. Now we are going to see what this system unit consists of. In system unit, first we are having memory unit. The memory unit is also called as MU, where memory is used to store data. Whenever we want to store data, we need memory. It may be a permanent memory or temporary memory. We need memory. So memory unit is an area where we can able to store data. There are two types of memory units. One is primary memory. Primary memory is first memory or important memory or main memory or semiconductor memory, where this primary memory can be divided into two types, namely RAM, RAM, random access memory, and ROM, read-only memory. And again, the second part of memory is secondary memory, where secondary memory consists of hard disk, flash, CDs, DVDs, etc., etc. And coming to next, we are having CPU, Central Processing Unit. Yeah, this is called as the heart or the virtual brain of a computer, where all the processing are taking place inside CPU, where Central Processing Unit or processor or microprocessor consists of arithmetic and logic unit, called as ALU, arithmetic logic unit, and control unit. A control unit is an area where it's used to control all the instructions and commands and flow of processor. And register, temporary storage. Whenever processor is doing a task, it needs a buffer area where it stores in temporary values. The place is called as register. And next comes the motherboard. Motherboard is very important because the name itself, it's a motherboard which feeds all other components, where all other components can be inserted on one board. That's why it is called as motherboard. Only link between other components can be established through motherboard. That's why the name motherboard. Here you can able to see this gives the complete classification of memory, where what is memory? Memory is used to store data. The memory can be divided into two types. One is primary memory or main memory or semiconductor memory. On the other hand, we are having secondary memory. The primary memory can be further classified into RAM and ROM. The RAM is further classified into static RAM and dynamic RAM, and ROM is further classified into PROM, EPROM, and EEPROM. Coming to secondary memory devices, we are having hard disk, floppy disk, optical devices such as CDs and DVDs, etc., etc. We are having one more diagram. This diagram gives a complete picture of a memory hierarchy. Here we are having memory. Memory can be divided into primary and secondary. In case of primary, we are having two subdivisions. One is ROM, read-only memory, RAM, random access memory. The ROM is divided into PROM, that is programmable read-only memory, and second one is EPROM, erasable programmable read-only memory, and EEPROM, electrically erasable and programmable read-only memory. In case of RAM, there are two parts. One is a static RAM, another one is a dynamic RAM. And in case of secondary storage devices can be classified into two types. One is of disk drives, and next one is a tape drives. In case of disk drives, we'll be having hard disk, floppy disk, and CD-ROM, that is a read only and write only, and we are having tape drives. Now we'll take a look on primary storage or primary memory. So primary memory is also called as main memory or semiconductor memory. So used to store data, and memory is directly accessible to CPU, and CPU constantly read the instruction stored in memory and execute them as required. The memory is directly or indirectly connected to CPU via memory bus. So here the primary memory is very important. For a computer, the primary memory is very important. Why? Because the primary memory provides data to the computer or CPU. So the CPU constantly reads the instruction through primary memory. In primary memory, we'll see RAM. RAM stands for random access memory. Before seeing RAM, we'll see the example for RAM. Here we can able to see some of the example. This is called as RAM. What is the use of this RAM? In case the secondary storage devices, for example the hard disk, and the primary storage devices, example RAM. So whenever process needs an information from hard disk, the speed of the hard disk is low and the speed of the processor is high. So what RAM will do? RAM will take the information from the hard disk and provide to CPU on demand. That is a major task of RAM. These are the various examples for RAM. And RAM is a read and write memory. So whenever data is needed for CPU, that can be write. Whenever the task has been completed, the data inside the RAM will be deleted. So what information will be stored in RAM? The RAM will store current running information. In a system, we may have any number of softwares, any number of programs, but simultaneously we can able to run only one program, and that one program data will reside inside RAM. So where the RAM gives information? RAM gives information from the secondary memory or from input devices. Where the processor get the data? The processor get the data from RAM. Why? Because processor is very fast. The speed of the processor cannot imagine, but the hard disk is relatively slow. Whenever processor needs data, somebody wants to take and give the data, because the speed between the processor and hard disk is not compatible. So to overcome this, we are having an intermediate version called as RAM. Whenever processor requires a data, RAM will randomly access the data and track all the information, and the tracked information will be provided to CPU whenever CPU needs the data. Once the task has been completed by the CPU, the current data will be erased from the RAM. So RAM chip circuit is made up of millions of transistors and capacitors. And types of RAM family. So as we talked about, there are two types of RAM. One is a static RAM, that is a static random access memory, and second one is a dynamic RAM, it's a dynamic random access memory. So what is the difference between static RAM and dynamic RAM? The primary difference between them is the lifetime of the data they store. So based on the storage or lifetime of the storage, we are having the classification static RAM and dynamic RAM. And we'll see what is meant by SRAM. S stands for static RAM. So static RAM retains its content as long as electrical power is applied to the chip. If the power is turned off or lost temporarily, its content will be lost forever. So this information stored in SRAM is a static information. Once the information is stored, the information will be as long as the power is on. Whenever power goes off, the information inside SRAM will be lost forever. And coming to dynamic RAM, and other side will be having dynamic RAM as an extremely short data lifetime, typically about millisecond. So this dynamic RAM will dynamically change the information. In case of static RAM will keep the same information as long as power is provided to the RAM. But in case of dynamic RAM will dynamically change its data, typically about a millisecond. So we'll see the RAM family. There are different types of dynamic RAMs are available. Some of them are synchronous dynamic RAM called as SDRAM, and RAM-based dynamic RAM called as RDRAM, and double data rate RAM called as DDR-RAM. So these are various RAM family types. And now we'll see read-only memory. And this is the diagram. This pictures shows the read-only memory. Here you can able to see read-only memory. This one, this one. These are the example for read-only memory. What is read-only memory? Memories in RAM families. See, the RAM read-only memory is a chip which initialize all other component. For example, when we switch on the system, somebody wants to load the hard disk, the motherboard, the processor, and other component like a sound card and video driver. Who's responsible for this? Yes, the answer is ROM, read-only memory. The read-only memory will initialize other components. When we switch on the system, the program inside the read-only memory will be executed. That program will initialize all the components like hard disk, processor, sound card, video card, everything. The memories, that is The memories in ROM family are distinguished by the method used to write a new data on them, usually called as programs, and the number of times they can be rewritten. See, what are the classification? How a classification can be done on RAM, right? So they are using various techniques to write a program on RAM. Based on the technique, they can classify the RAM, and based on the number of times they can able to reuse or rewrite the programs on the same RAM, we can able to have a classification. And it is also called ROM BIOS, read-only memory, basic input and output system. So here, as I said, the basic input and system, keyboard, mouse, everything has to be initialized at the time of starting a computer. Who is responsible? The responsibility goes to ROM, read-only memory. Read-only memory will initialize all other components like keyboard, mouse, printers, everything it will initialize. ROM is non-volatile. Whenever power is not supplied to RAM, the program inside the RAM remains. It is called as volatile, non-deletable, non-evaporatable. It's called as volatile memory. So ROM can be further classified into PROM, is a programmable read-only memory, and one more type is erasable programmable read-only memory. Here only programs can be loaded, and loaded program cannot be edited or deleted. Here this we can able to erase, and we can able to put one more program, and here we'll be using WE, that is electrically erasable and programmable ROM. We can use electrical methods to erase and to install new programs. And NV RAM, that is non-volatile RAMs. So difference between, what is the difference between RAM and ROM? And before that we'll see what is processor. And you can able to see this diagrams gives you a complete picture of a processor. This is a processor, it's a processor, this one is a processor, this, all the diagrams right here are processor. What is a processor? The processor is called Central Processing Unit, CPU, or microprocessor or processor. So it consists of the following unit. First one is control unit. So control unit controls the operation of CPU or processor. Control unit will control the execution, control the speed of the processor. And next we are having arithmetic and logic unit. So here this arithmetic and logic unit performs all arithmetic and logic operations like addition, subtraction, whatever task, the task will be carried out only in arithmetic and logic unit. The central processing unit is also called as brain or heart of a computer. So what a processor will do, a processor will do all computational tasks, all calculation part will only done by your processor. A processor is similar to a human brain. Our human brain will do all the tasks. All other parts will carry the information to the brain. Brain will work based on the instruction or based on the data. As well as the speed of the processor is very high. The processor used to process the information or used to refine the data into information. And what is register? And whenever CPU or processor is doing a task, it needs some memory to store intermediate values. Yes, register is a place where we can able to store the intermediate values. So here they are the storage location used to store essential information for CU and ALU. That is during the calculation, the control unit and logical unit, arithmetic and logical unit, needs buffer memory to store their intermediate values. A register is a place where CU and ALU can store their intermediate values. A register is essentially a storage place inside the CPU. The register is used to hold numbers that are currently being manipulated. As you said, a CPU is currently doing a task. If I say 1 plus 8 plus 9, what we'll do calculation by help of our hands, with help of pen or pencil. We need something that is called as memory, some additional things. Likewise, whenever a task is assigned to a CPU, if CPU want to do the task, it needs a buffer memory, a temporary storage called as register. The size of the register is expressed in bits. A bit is a single binary digit. A bit means either it takes the value 0 or 1, or true or false, or on or off. So these are the various values a register can hold. Either a register can hold 0 or 1. Bits are usually groups into set of 8 to form a byte. See, we are making a combination of 8 bits. 8 bits put together, we can call it as a byte. One byte can express a number between 0 to 225. One byte can write 1 byte, that is 8 bits can able to express a value between 0 to 255, right? If you convert the 0 to 255 into binary values, we can use 8 bits to specify this value. That's why we used to call as a byte, right? Oh, data bus. A data bus is a pathway connecting to the microprocessor to the memory storage. It is used to transfer program instructions and data from memory to CPU and back. What is a data bus? There are two types of bus. One is a data bus and other one is an address bus. Bus means which it's a pathway where the data can travel along with. Here data bus, this bus will take the data and deliver, just like a bus. Bus will take the people and deliver to their places, corresponding places. Likewise, here the data bus will take the data and deliver the data accordingly. And next comes, it affects the computer performance because it determines how much data can be moved and therefore processed at the same time. As I said, the processor is very fast, and the processor should be provided with data whenever the processor needed with the speed of processor. But there are various factors which decrease the speed of processor. For example, whenever process need a data, somebody wants to provide the data. Whenever the provided data wants to travel to CPU very fastly. So here bus plays a vital role, right? The information needed by CPU will be placed by RAM, and from RAM it wants to reach CPU through bus. Here you can able to see all the diagrams, right? This are called as bus. The pathway connecting between the components is called as bus. Here's speed. The speed with which a microprocessor operates on depends on two factors. The speed of a microprocessor or a CPU depends on two factors. One is microprocessor design. The manufacturer specifies certain range. And second one, the speed of the system clock. That is, the clock oscillates or ticks at certain frequency. In general, This frequency is several millions per second. Expansion slot. Expansion slot allows you to expand any new additional components into motherboard or system unit. Here you can able to see the white color slot. It is called as an expansion slot, where we can able to plug in the new hardwares. The speed of the microprocessor is measured by the number of cycles per second, which is expressed in the unit of frequency called as Hertz. Whenever, if you are going to buy a computer, you're asking the speed of the computer. Let us say, what is the speed of processor? 1.3 GHz, 1.3 MHz. If you are buying a phone, smartphone, there also you are having processor. There also they will be saying go to do your 1.3 MHz. So the speed of a processor can be defined with Hertz, with the unit Hertz. Processor and multiprocessor. So they are the technologies that allows more than one CPU to operate concurrently in executing programs. These technologies allows one or more CPU to operate concurrently in executing programs. And in case of memory unit, if you want to measure the size of memory, here is the term. We already seen 8-bit is equal to 8 bits. 1 byte is equal to 8 bits is the smallest unit that can be directly addressed by most. 1 kilobyte KB is equal to 2 power 10 bytes, that is 1024 bytes. The word kilo means in case of computer 1024, it's not 1000. And then 1 megabyte is equal to 1024 kilobytes, and 1 gigabytes GB is equal to 1024 megabytes, and then comes 1 terabytes TB is equal to 1024 gigabytes. Here you can able to say this is nothing but a bit. 0 1 2 3 4 5 6 7, right? 0 to 7, the count is 8. So this value, this 8-bit can use to express the value between 0 to 225. Here again, once again we'll have a look. 1 byte is equal to 8 bits, and 1 kilobyte is equal to 1024 bytes, and 1 megabyte is equal to 1024 kilobyte, and 1 gigabyte GB is equal to 1024 megabyte, and terabyte TB is equal to 1024 gigabyte. This is an example for a byte. A byte is used to store 8 bits of information. A bit means either 0 or 1. Here 0 1 2 3 4 5 6 7, 0 to 7, the count is 8. So here 1 byte is used to store 8 bits of value. And next comes to secondary memory. Secondary memory is also called as auxiliary memory. The large storage amount of data. The speed of secondary memory is slow, but the speed of primary memory is fast. But the data can be stored or deleted as per the user requirement. The secondary storage memory is also called as removable media. As we saw, the secondary memories are very slower comparing to primary memory. Their primary memory are very fast. Here the secondary memory is very slow, but the storage capacity of primary memory is slow, but the storage capacity of secondary memory is large. Example for secondary memory: hard disk can be called as HDD, compact disk, CD, and DVD, digital Versailles disk, floppy disk, and flash disk. So these are the example for floppy disk. So floppy disks, which are inexpensively cheaper, flexible magnetic disk, which is encased in plastic. The floppy disk can be inserted or removed from the drives. There are three types of floppy disk: 8 and 5.2, 3.5. There is 8-inch and 5.25 and 3.5 hard disk types are available. And next comes your digital Versailles disk, where DVD is used to store more number of data. DVD is the most common types of remote storage devices. Nowadays we'll be using DVDs for songs and videos. DVD drive is used for reading data from DVD, and in case of DVD both reading and writing operations can be done. Maximum capacity for DVDs comes with 4.3 gigabytes. And next comes your hard disk, where hard disk is a massive area where we can put a lot of information on hard disk. Hard disk can be called as HDD. Hard disk is used one or more rigid magnetic plotters to hold. Hard disk have their magnetic disk seals inside permanently. Anyway, hard disk is a massive area where we can able to store a lot of informations like songs, videos, program, operating system, application softwares, all the things. And next comes your flash drive. It's also a secondary storage devices where we can able to see flash drive, memory stick. A flash drive is a compact device for the size of a pin, common in various shapes and style design. It's a plug-and-play device that simply plug into USB port of a computer. USB means universal serial bus. USB flash comes with various memory sizes like 4GB, 8GB, 16 and 32GB. And coming to output devices, and common output devices, here we can able to see a monitor, printer, speaker, plotter, or common output devices. A monitor is a visual display unit. The computer screen is used for putting the information in an understandable format for humans. Whenever humans want to see as a visual display, we'll be using monitor. Printer used to print the information, and this is monitor, and this is printer. Whenever you want to see the output in a form of document, we'll be using printer. And this is a plotter used to print large images. Speaker enhance the values of educational and presentation products. Speaker, we can able to hear the sounds. This is an example for speaker. Thank you for being with us, and let me have one more session for the same. Thank you.